Dear students, welcome back. Today we are going to continue with few more sums based on uh, surface area, area of combined figures. Before we start today's questions, let me tell you that in this class I have posted your solution PDF of your class 10 subjective assessment exam. So you go through that solution and you can tally your answer sheet with those solutions, and you can make out where is the mistake in your in your in your answer sheet. Okay, so still after doing that, still if you have any doubt, you can message me on my personal number. So the first question for today: ABCD is a trapezium. It is given that ABCD is a trapezium. In the given figure, ABCD is a trapezium with AB parallel to CD. As you can see, AB is parallel to CD, and angle BCD is 60 degrees. This angle is given 60 degrees. Okay. Now, BFEC is a sector of a circle with center C. So now taking C as the center and CB as the radius, you draw a sector of a circle like this. And they have given that this point is E. And suppose this point is F here. So it is a sector of a circle, clear? So obviously this BC and EC will be equal. Clear? Now, it is given that AB is 7 centimeter, AB is 7 centimeter, and BC is also 7 centimeter. So this is also 7 centimeter, and as I told you, CB and CE will be equal. So this is also 7 centimeter. Clear? And DE is 4 centimeter. This DE is 4 centimeter. Then find the area of the shaded part. You have to find the area of the shaded part. So this part is shaded. So you have to find the area of the shaded part. As you can see, to find the area of the shaded part from the area of the trapezium, we have to subtract the area of the sector of the circle. It is very easy to calculate the area of the sector of the circle because the radius is given, the angle is given, it is easy. But to find the area of the trapezium, you know the formula for area of trapezium. Area of trapezium will be half A plus B, that is sum of parallel sides, into H. Now this side is 7 centimeter and this side is 11 centimeter. So we know two parallel sides, but we don't know the height. We have to find the height. Now to find the height, then only we can find the area of the trapezium. To find the height, you draw a perpendicular from that point on this line DC, and suppose this is H. So first of all, in triangle B, let this point be say G. So in triangle BGC, In triangle BGC, sine 60 is equal to perpendicular upon hypotenuse, so h by 7. You know that sine 60 is root 3 by 2 is equal to h by 7. So h is equal to 7 root 3 upon 2. H is equal to 7 root 3 upon 2. The value of h is 7 root 3 upon 2 centimeter. Now, the area of trapezium will be half sum of parallel sides. One side is 7 and the other side is 11 and 7 root 3 by 2. That is the value of h. Now you see 11 plus 7 will be 18. So half into 18 into 7 root 3 by 2. So it is 63 root 3 by 2 centimeter. Now area of sector. So the area of the entire circle is pi r square, all of you know. So pi is 22 by 7, r square means 7 into 7, and here the angle is 60 degree and the total angle about a point is 360. So you will write 60 upon 360 here. 60 upon 360. Now 7 gets cancelled and it is 77 upon 3 centimeter. I'm sorry, it should be centimeter square. Here also 77 by 3 centimeter square. That is the area of the sector. Now to find the area of the shaded part, area of the shaded part is equal to 63 into 1.732 upon 2 minus 77 upon 3. 63 into the value of root 3. Okay, they have given it is 1.73. So the value of root 3 they have given 1.73. So 63 into 1.73 upon 2 minus 77 upon 3. Now you see 1.73 when it is multiplied by 63. And now it is divided by 108.99 divided by 2. So it is 54.495. 54.495 centimeter square for the area of the trapezium. And now 77 upon 3. 77 divided by 3. $25.67. 25.667 you can say. As the first one is in up to decimal, 3 places of decimal. So second one also you write up to 3 places of decimal. So 25.667. Now you subtract from 54.495. You subtract 25.667. So the answer is 28.828. The answer will be 28.828 centimeter square. When you subtract, the answer will be 28.828 centimeter square. Clear? So that is the area of the shaded part. Clear? Now the next question, next example. Once again, there is a trapezium ABCD. ABCD is a trapezium and it is given that AB is parallel to DC, as you can see. AB is parallel to DC and the length AB is given 18 centimeter and length DC is given 32 centimeter. Okay, and the perpendicular distance between AB and DC is also given, which is 14 centimeter. This is given 14 centimeter. The perpendicular distance between AB and DC is given 14 centimeter. Now, if arcs of equal radii of 7 centimeter have been drawn with centers A, B, C and D. See, with A as the center, you draw an arc. With B as the center, you draw another arc of the same radius, that is 7 centimeter. With C as the center, you draw another arc with the same radius. And with D as the center, you draw another arc with the same radius. Now, you have to find the area of the shaded part. Means this. You have to find the area of this shaded part. Now see, to find, okay, it is given that the radius is 7 centimeter. All radii, they are 7 centimeter. Same. Okay. Now you see, if to find this area of the shaded part, what we have to do, from the area of the trapezium, we have to subtract the area of the 4 sectors. So, area of shaded part is equal to area of the trapezium minus area of 4 sectors. Now see, the area of trapezium is half into sum of parallel sides into perpendicular distance between the parallel sides. So it is half sum of parallel sides, that is 18 plus 32, and the area of the 4 sectors, that is, now you see, that is into perpendicular distance, that is given 14, that is area of the trapezium, minus area of 4 sectors. Now if you pay attention, you know that the sum of the 4 angles of a quadrilateral is 360. That means this angle plus this angle plus this angle plus this angle plus this angle is nothing but a 360 degree. That means these 4 sectors, they together make a complete circle, as all of them have the same radii. So these 4 sectors, they make one complete circle. So it is equal to simply pi r square. Okay, so you cancel it by 2, this one 7, 32 plus 18 is 50, 50 into 7 minus 22 by 7 into 7 into 7. So 50 into 7, 350 minus 154. Now you subtract 196 centimeters square will be your answer. 350 minus 154, that is 196 centimeters square is your answer. Clear? Now the next question. The next question says that there is a right angle triangle ABC. ABC is a right angle triangle with AB 3 centimeter and AC 4 centimeter. Now, taking BC as the diameter, a semicircle is drawn like this. So if taking BC as a diameter, you draw a semicircle, it has to pass through A because you know that angle in a semicircle is always 90 degrees. So it will pass through also A. Now what happens? Taking AB as the diameter, another semicircle is drawn like this. And then taking AC as the diameter, another semicircle is drawn like this. And now you have to find the area of the shaded part. This is the shaded part. Okay. So if you see, to find the area of the shaded part, in the area of the triangle, you add the area of two semicircles with AB as diameter and with AC as diameter. Then this will make the whole area. This is the whole area, and then from that you subtract the area of the biggest semicircle with BC as the diameter. So you will get the area of the shaded part. So before that, I must tell you that using Pythagoras, you can easily calculate that BC will be 5 centimeter. Because in a right angle triangle, you know, perpendicular square plus base square is equal to hypotenuse square. That is the Pythagoras theorem. And the Pythagoras theorem says, according to Pythagoras theorem, this side BC will become 5 centimeter. Now see, area of shaded part is equal to area of triangle ABC plus pi r1 square, means say this radius is r1, then plus pi r2 square, I'm sorry, pi r1 square by 2 as it is a semicircle, and then pi r2 square by 2, say this radius is r2. Okay, so pi r1 square plus pi r2 square, and say this radius is r3, so minus pi r3 square by 2. Clear? Okay, pi r1 square by 2 will be the area of this semicircle, pi r2 square by 2 will be area of this semicircle, and pi r3 square by 2 will be area of this bigger semicircle that you have to subtract. Now first of all, area of triangle ABC, half base into height, so half into 3 into 4, plus you can take pi by 2 common. So when you take pi by 2 common, it is r1 square plus r2 square minus r3 square. Okay, now what happens? 6 plus, they have given the value of pi over here or not? No, they have not given. So we'll take it as Okay, we'll put the value of pi later, pi by 2, and then see r1 square. R1 is what? 3 by 2. So 3 by 2 square will be 9 by 4. R2 square. R2 will be what? 2. 2 square is 4. And R3 square. R3 will be 5 by 2. Square of that will be 25 by 4. Okay? So 6 plus pi by 2. Now here you take 4 LCM. When you take 4 LCM, it will be 9 plus 16 minus 25. Now you see very interesting thing. 9 plus 16 is 25. 25 minus 25 will be 0. So this entire thing will become 0 and your answer will be 6 centimeter square. The area of the shaded part here will be 6 centimeter square. I hope you are doing your projects and your math activities, because I told you try to finish them as soon as possible so that any day I can call you to submit those activities in the school. So that's all for today. In the next class, I'll start surface area and volume. Thank you.